All right. Two special patterns. Special patterns. That reminds us. Let's do it now. Okay. Difference of two squares. I'm just kidding. All right, so tell me what a square is. Not geometrically. Algebraically, what's a square? Something times itself twice, right? And so I'm going to let this say a squared minus b squared because difference means subtraction. That's the key to this one. If there is an addition sign, it does not work. It's only when it's a minus sign, okay? Difference of two squares. If you see this and you're asked to factor, so you've got two perfect squares, the way it factors is the square root of both of them with a minus sign and then the same thing but with a plus sign. There's no slashing, there's no multiplying and finding factors. So the one that we did, only if it's a minus. Okay, so the one we did that y'all said was a beast earlier, what was it, 49 and 16. Do you recognize that both of those are perfect squares? Yes. Yes, because what times itself twice gives you 49x squared? 7x. And what times itself twice gives you 4. And there is a minus sign, so this would factor as 7x minus 4, 7x plus 4. So it wouldn't have to multiply those two values together and find what multiplies to that but adds to 0. Little bromance going on back there? All right. Does that make sense? No. If it were 49x squared plus 16, that's a CBF. Okay? If it's plus, it does not work. It has to be a minus. Yes? If they're both perfect squares and there's a plus, it's not going to factor for you. It's not, because there's not going to be anything that you could do to make it add to 0, but it's got to multiply to something positive. It's just not going to happen. All right. Do I need to do any more of those, or can we move on to the second special pattern? Okay, because that was pretty easy, and I hope you almost picked, if you did enough of the homework problems, I hope you kind of picked up on that last night or the weekend. All right, here's the hardest one. I saved the best for last. This one everybody always says, but do I really have to learn it? Well, I'm not going to say that you have to learn it now, because right now you could go through grouping everything, but by the end of this chapter, you're going to have to know this pattern. So, why not learn it now? This one's a perfect square trinomial, and it's a little bit harder to recognize, okay? I'm going to run you through the criteria for a perfect square trinomial. Now, first of all, trinomial we know means what? 3 pieces. So 3 terms, right? So 1, 2, and 3. And I'm going to set up 2 of these because it can go either way. All right, criteria number 1 is that the second sign must always be a plus. And I'm going to even put a 1. Let's see. Second sign is a plus. The second criteria is that the ends are perfect squares. Am I confused so far? Those are the easy parts, yeah. Everything, it has to meet all criteria. Yep. Yeah. Okay. The middle term. Okay? The first sign could be a plus or a minus, so there's no criteria there. I'm setting up two different scenarios here, so that's not a criteria. The last criteria is that the middle term has to be double the product. Product means multiplication. Double the product of the square roots of the ends. Whoa! That means take the square root of the first one, take the square root of the last one, multiply them together, and double it. Okay? That's what's got to sit in the middle. Well, but these aren't going to be A and B. These are going to be like 49x squared and 16. Okay? Doubled. Right. And that'll be what's in the middle. But what you'll start to see is just like that, the numbers get so big so fast, if you were to have to group them and slash it, oh my goodness, it gets big. So the nice thing about this, though, is if all this is true, so this is criteria number 3. If all this is true, the factor is super, super, super easy. This first one will factor as A, the first sign, B squared. So the square root of the ends with the first sign in the middle. And the last one, and this, if you don't understand it with variables, I'm fixing to show you with an example. Some people understand the variables better than an example, and some people vice versa. This one would be A minus B squared. Okay? So when we did the warm-ups, there was one, the very first one we did, and I said, bless you. I said, now how else could you write this, right? And y'all told me. So if you have that warm up, I don't have it right in front of me. What was the problem?
X squared minus 12x plus 36.
Okay. And this is an easy one because there's no leading coefficient. But let's just run through the criteria. Second sign's a plus.
Yes.
The ends are perfect squares.
Yeah.
The middle is the product of, or double the product of the square roots of the ends. All right, so let's think about that for a minute. What's the square root of x squared? 1x, right? What's the square root of 36?
6.
If you multiply those two things together, you get 6x, and you double them.
Oh, okay. Wait.
Don't worry about the sign right now. Don't worry about the sign. Because remember, the first sign can be plus or minus. Okay? If that's true, and it is, then it factors as x, the first sign, remember this is where the sign comes into play, 6 squared. Is that what we got when we grouped it? Yes.
And that's it?
Mm-hmm. Let's look at, yeah.
Oh.
Yes.
I was confused. The end is B squared, so that would mean, I guess that, I was wondering why you had 6, so I guess that each 6 squared. So you could put 6 squared.
You can put 6 or say that again. You kind of start getting quiet at the end.
Okay. So like.
And I might should have used variables that weren't A and B. Is that confusing you? Because the standard form of a quadratic is A and B and C. Is that what you're talking about? No. Okay, go ahead with your question. Okay,
In the example.
Yes.
Squares at the end.
Mm-hmm.
And so like. That would mean that B is 36 on that.
That would mean, and I think I did confuse you using the variables that I used. I wasn't referring to, oh my goodness. I'm not referring to these A, B, and C. I'm just saying in general, if you have something squared here and something squared here. So in this case, the B would be 6. So then B squared is 36. If you can rewrite it as a squared, and then you take these two numbers, multiply them, and double them to get what's in the middle, it's a perfect square trinomial. Let me show you another one. Is that what you're saying? Okay, I apologize. You're right.
But basically, because it could be rewritten as
Yes. Yes, it can. It can. Let's do this one. First of all, I want you to tell me, is it a perfect square trinomial? Because as you factor now, remember our first step was always to check for a GCF. That still stands true, but now I also want to check, after I check for GCF, I also want to check for a special pattern, because if it has a special pattern, there's no point in me going through and grouping it and going through all that headache if I can just recognize the special pattern and be done, okay? So, does it have a GCF? No. Does it? I don't think so. Is it a special pattern?
Yes.
Yes. So what caused you to recognize that this was a special pattern?
64.
That's exactly what I see first. The first thing I recognize is that the ends are perfect squares. Just right off the bat, I see perfect squares on the ends, right? After that, then I go through, well, if the ends are perfect squares, let me go through and check. Is the second sign plus? Yes. And then, and Miss Wilson calls this square dancing when she teaches it. She says square, square, multiply and double, but she kind of sings it and dances when y'all know how she is. So does it square dance? Does it meet that middle criteria? Yes, because what's the square root of 64x squared? 8x. What's the square root of 91? God. 9. Okay. If you multiply those together, you get 72, and 72 doubled is 144. So that also checks. So it's 8x. First sign plus 9 squared. Now, if you had to do this by grouping, 64 times 81 is a huge number, right? Like, OMG, I don't even know. And then not only that, but it's got to add to 144. Good luck with that, right? So, 5,184. And then you got to find what multiplies to that but adds to 144. So being able to recognize these patterns really helps out with the factoring. Does that make sense so far? All right. We're going to switch gear. Here we go. All right. So I'm going to relate this back to graphing, okay? So I'm going to pick your brain a little bit more. I know. I'm so sorry. All right. Think about this for just a minute. How do you actually tell me... If I'm talking in terms of graphing, what form is that in? Just sleep there. It's the intercept. It gives you, what'd you say? X-intercept form, right? It gives you the x-intercepts, the places where it crosses the x-axis. Are we all in agreement there? Remember, it gives you those 2 points. This would be -2 and 3, right? When you find intercepts graphing, whether you're graphing a line or a quadratic, whatever it is, when you find x-intercepts, how do you do that? What happens at x-intercepts? Okay. What else happens? Like if you were just given an equation and I said, what are the x-intercepts without graphing?
You would plug in a 0.
You would plug in a 0 for y, right? Because at the x-intercept, at every x-intercept, y is 0, and at every y-intercept, x is 0, right? That's what happens. So here, do you understand why, if this is an intercept form, if I put a 0 here, why are -2 and 3 my solutions here? Why are those the intercepts? If y is 0, but how would you solve that, I guess, is what I'm getting to. That's what makes the equation equal 0, right? If I put a -2 in for this x and this x, this first parentheses would be, what's -2 plus 2? 0. And it doesn't matter that this one's -5 because 0 times whatever is 0. And then vice versa, if I plugged in +3, well, this one would be 5, but the second one would be... So both of those values would make my equation equal 0. Does that make sense to you? Okay, so essentially what this is saying is, if I've got, and this is a big, big, big property that you already know, you just don't know that you know it. If I'm multiplying things together and they equal 0, then what do you know about one or more of those things that I'm multiplying together? 1 or the other's got to be 0, or both, right? So either x plus 2 has to be 0 or x minus 3 has to be 0. There's no other way to get 0 when you multiply, right? This is called the zero product property. Zero product property. And it doesn't matter if there's 10 things multiplied together or 2. When they're multiplied together and they give you 0, 1 or more or all have to be 0. So to solve these type of equations, we would get them factored and then we would set each piece and solve. Okay? In other words, if we started with y equals x squared minus x minus 6, in order to solve that for x, I would need to first factor it and then set each piece to 0. Does that make sense? Somewhat? Okay. I'm going to write that under here. Factor, actually, if this was not y, this was 0. That's my fault. Factor, and then do the zero product property. The ZPP. Yes.
So when we do the ZPP, we only have to make, like up there, we only have to make one of these.
Well, but you want to find all the solutions. You want to find all the intercepts. So you would, each piece would go to 0 and you'd solve it.
So it would be like, we'd set it up like x plus 2 is 0 and x minus 3 is 0.
Yes, yes. So you'd have minus 2, x equals negative 2, which y'all already told me that's where it crossed, and add 3, x equals 3. So you have 2 solutions. Instead of doing them graphically, we're doing them algebraically now.
Okay, so we have to work it out. We could
Yeah.
use like the intercept, like it's just the opposite.
You could if you saw, I mean, if you came here, if you got to this point, then you said, okay, x equals negative 2, x equals 3. I'm okay with that. I mean, those are pretty easy solves. And you know that, you know by intercept form that those are the intercepts, yeah. All right, so the key to this, most important before you start, before it's factored and everything else, is they always, always, always must equal 0 before you start, because you can't use zero product property if you don't equal 0 first. So if they don't, you must make them. So always equal 0. So the only thing we're tacking on from the factoring is making it equal 0, and then after we've gone through the steps to factor, we're going to set each of those parentheses to 0 and solve. I just wanted you to see why it worked and how it tied back into the factoring part. All right, so let me show you all, for instance. Let's do, let's say 3x squared plus 10x minus 8. Of course it's, tough lesson today. Okay, always equal to 0. This one equals 0. Once it equals 0, I want to factor it, okay? Factoring is the key always. In this class, if you ever have a question, you don't know what to do, and you go, oh my gosh, I'm stuck. You go, oh wait, can I factor it? Because that's probably the answer. As we go through, yes.
Is this going to be a problem?
Yes.
So is it going to give it to us already equal to 0?
Not all. I'm going to do one that doesn't equal 0 to start with and show you what to do if it doesn't start that way. I'm just starting you out with an easier example. But that's a great question. No, they won't always equal 0 when you start. Sometimes you'll have to manipulate them to make them equal 0 and then factor and solve. All right. Negative 24 adds to 10. No. Like, what adds to 10 but multiplies to negative 24?
Negative 12, no, wait.
Yeah.
But
It's 12 negative.
it's 12 and 2, but the 2 is negative to make it positive. Yeah. A lot of you said 6 and 4, but because it's a negative 24 and a positive 10, we've got to take that into account. So be careful. And I'm glad y'all said that because that's where a lot of students make mistakes on that, okay? All right, so I got 3x squared plus 12x minus 2x minus 8 equals 0. Slash it. Somebody did the...
That was gosh.
All right. Some of you, I see you just writing because you're factoring on your own. That's wonderful. X plus 4. That second sign changes because the middle sign is a minus. And so this is already getting to be second nature for you to factor like this. That's awesome. So here's the new part. Are we in agreement that we have two things multiplied together to give us 0? So if that is the case, then one or both of them must equal 0. So, 0. I said it. It was Spanglish, y'all. Y'all know I speak Spanglish. I got to put my country. Yeah. All right. I'm going to set each one of them to 0. And so x is negative 4. Or actually, let me take it 2 steps at a time for you. This is technically solving like this is an Algebra 1 standard. Yeah. Can't see it? Let me hit record on this. It's a Corbin problem. The problem is what, as I go to solve this, because the directions are only going to say solve. They're not going to tell you what to do. Yeah.
So they're on the homework tonight. They're all going to have it equal something.
Yes.
Wait, I'm confused. So could you subtract?
It doesn't equal 0. Yes. Okay. Remember, you want to keep your leading coefficient positive. Leading coefficient is the first one that's hooked to the squared term, right? And so some of you said in unison that we move the 4x and the negative 5, and that is exactly right. To move it, we do the opposite, right? And so if we do it to the left side, we must also come over here, and I'm just going to line it up under the like terms that it goes with. And so I have 5x squared minus 20x plus 20 equals 0. And so now my factoring takes over. First step of factoring is, yes, you're exactly right. It has a GCF. Okay. And it's 5. Ooh, something else, something else. It's not a hard factor, but something else about the parentheses. Oh, who sees it? Who sees it? Who sees it?
It's the trinomial thing. Yes. It's like
It's the trinomial thing.
I said it first. You just said it louder.
All right, second sign is a plus. The ends are both perfect squares, and it does square dance. Square, square, multiply, and double. I wish she was here today. I would get her to come over here and dance and sing it for you, but she's not here today.
I'm really happy that was her.
Call her right now.
She's at the dentist. Hello, Miss Wilson in the dentist chair. Would you please sing this? I'm going to put you on speakerphone.
What if she's like laughing? Yeah. You see like.
Yeah, I know. Ah! Okay. So it factors as the square root of the first one is x. The first sign is minus. The square root of the last is 2. And so it's much easier than if I were to slash it and group it. Now hold on, because this is different, okay?
Yeah.
There's something in front. Remember that zero product property. If one or more things multiply together to give you 0, one of them has to be 0. 5's being multiplied. 5 ain't never going to be 0. 5 ain't going to be 0 no matter what it does. It ain't never going to be 0. So that doesn't have any bearing on my solution.
X is 2.
X minus 2 is twice. So I don't need to write it twice. I don't need to solve it twice because I'm going to get the same thing both times I do. So in this case, I only have one x-intercept. What does that mean? What does it mean to only have one x-intercept graphically? It's a point.
Then you have a regular line instead of a...
What kind of parabola would only have one x-intercept? You're exactly right. The vertex. The vertex is sitting on the x-axis, and then it's either going up or down from there. It crosses one place, and that is the vertex.
So we got something like this.
For example, this comes up every single time, and I always forget to go over it, so I'm glad I'm remembering. Let's say I have 5x squared minus, I don't know, 16x equals 0, and I'm asked to solve for x. Okay, so I see a quadratic, and I know it's a quadratic because of the squared, right? And anytime I see a quadratic, I know it needs to equal 0, and it already does, so I'm good to go there.
Yeah.
So now I think, okay, I need to go through some factoring steps. So the first factoring step is GCF. Does it have one?
No, it doesn't.
What?
Yeah.
One what? X. They both have an X, right? So take it out. What is left? Can I factor that any further? No.
As a matter of fact, you can't.
You are exactly right. You cannot. But. Oh my goodness. Somebody had to do it. Okay. I've got two things multiplied together give me 0. Yes. So before we had a 5 in front. We said it doesn't matter what 5 does. 5 is never, ever, ever going to be 0. And you're exactly right. But x can be 0, right?
Yeah, it can be.
That is one solution. But in this case, I have two solutions because not only could x be 0, 5x minus 16 could be 0. And so if I solve that, see why I like fractions better than decimals? Y'all go ahead with your bad selves and your decimals. That's it. 2 answers.